Right, Alvarez found this ash layer, sampled it in Gubbio, Italy. But if we had anything so devastating that it would create climate change all over the Earth, we had an ash cloud that was thrown up that would go into the atmosphere. Presumably we should be able to see evidence of that, not just at Gubbio, Italy, but at other places in the world. And so immediately, scientists began to fan out and look for the Cretaceous-Tertiary boundary at other locations. This is the late Clay Smith, a professor in the department here when I came to New Mexico Tech. And in the 1980s, Clay and I went up to the Raton Basin in northeast New Mexico and met with a geologist from the USGS who took us to this particular section. And Clay's finger is on the Cretaceous-Tertiary boundary here in New Mexico. That boundary had already been sampled and analyzed by geologists at the USGS in Denver. And guess what? It turns out that it too had an interesting signal associated with it. On this diagram here is a graphic depiction of the stratigraphic section in the Raton Basin. And the dots that you see right here are the iridium abundances at PPT. And you can see that they're relatively low until we get to this level right here, and here they pretty much go off the chart again. So not only in Gubbio, Italy, but in Raton and in a growing number of places around the world, we find high iridium abundance developed at the Cretaceous-Tertiary boundary. Really starting to look like this is a convincing argument for meteorite impact being responsible for this. This is a later map showing known locations of iridium anomalies, high iridium amounts, at the Cretaceous-Tertiary around the world. And you can see here that there are many of them, particularly in the area of the Cretaceous Seaway in western North America. Remember, sediments can be reworked and redeposited if they're deposited on land. So if they were deposited in water or in lakes, that would work better. But we also have iridium anomalies in Cretaceous-Tertiary sediments within the ocean basins in Europe and in the South Atlantic, even in New Zealand, India, and elsewhere. We have iridium abundances. So now it's really starting to look as though this idea of meteorite impact has some plausibility to it. We're getting a little ahead of the game here, but the numeral 1 that you see here is the location of what turns out to be the candidate, the prime candidate for the meteorite impact location. This is Chicxulub impact crater, which is just off the north coast of the Yucatan.